Hello and welcome to our second IHS CTI webinar on the e-mobility decade, which is the second we did after the first one in September. And we're happy that we are doing again a webinar on automotive industry hot topics with IHS. My name is Silvia Zenzinger. I'm the conference director of the CTI Symposium. And in connection with the CTI Symposium, we have a long relationship and cooperation with IHS. And this is how it came that we are doing this second webinar to keep you updated until the next events take place. So the next CTI Symposium is on 13th and 14th October. So there are some weeks to go. And to keep you informed on what's happening in the industry, we have set this webinar together with IHS. So just a short welcome from my side. I'm happy that you're here, and I invite you to join this and carefully listen to what the experts say, but as well, we have a Q&A after the presentations, and you are highly invited to post your questions and get the answers to your personal questions directly from the experts. We will have 3 speakers during this presentation of IHS. So you have to be patient a bit. So we have 3 experts, highly experts here, and afterwards you can ask your questions. And now I directly hand over to Dr. Hamid Wahabzadeh, who is the chairman of the CTI Symposium USA, and he will moderate and share this webinar and coordinate the questions, and will lead the Q&A session afterwards, and we will see each other at the end of the webinar. So I hand over to Hamid. Thank you very much and enjoy the webinar.
Thank you, Silvia. I appreciate it. Hello and a warm greetings from my side as well. I would also like to welcome you all to our joint CTI IHS webinar today, which is titled the E-Mobility Decade, a holistic assessment of critical technologies and supply chain dynamics. As you all know, today we have an international audience with participants from around the globe. Our speakers are also participating from around the globe in different time zones and some in their late evening hours. So thank you all for taking the time and participating and presenting them the great material we have prepared. As we have all witnessed during the past few years, the battery electric cars are getting more and more attention for a variety of reasons, whether it's global warming, legislation, cost, etc., etc. We have all seen forecasts showing significant growth for battery electric vehicles in all regions of the world. Some regions are leading this race and some are following. Nevertheless, the race is on, and we see more and more developments all over the globe and more products being produced on a continuous basis at an unprecedented pace, never seen before. Despite many success stories in this field, despite many successful products that have been launched, there are still many challenges that remains to be solved for faster and better implementation of this technology. Battery energy density and cost, battery thermal management, inverter design, e-machine designs, and performance of all of these components. And finally, e-axles types and number of speeds are among the hot topics being researched and discussed around the globe. And this is what makes life interesting for thousands of engineers, managers, executives, and investors active in this field. In this webinar today, we try to tackle some of these issues with presentations by some of our key experts at IHS. We will have a Q&A session following this, so please submit your questions if you haven't done so previously, and we will try to get to all of them as much as possible. Now I have the pleasure of introducing our presenters from IHS. I believe we will start first with presentation by Mr. Claudio Vittori. Claudio is a senior technical research analyst in powertrain and e-mobility component research and in the automotive industry and supply chain and technologies. Claudio is a senior research analyst, as I said. His research areas include technology forecasting of e-mobility components with a specific focus on electric motors, power electronics, and charging infrastructure. Claudio has 8 years of experience in e-mobility, having worked for charging station manufacturers, research institutions, and an e-vehicle startup in Switzerland and Germany, and of course, Italy. Claudio is based in Italy. Then the presentation will continue with Dr. Richard Kim. He's the principal analyst at IHS Markit Automotive Supply Chain and Technology. Dr. Kim is a principal analyst of supply chain and technology based in South Korea. His responsibilities include e-mobility components, technology forecasting, and he has a specialty in e-mobility batteries, and that is one of the hot topics these days. He majored in mechanical engineering and completed the master's and doctorate degree in management of technology. His academic interests lie in technology forecasting and technology innovation in automotive industry. And finally, the presentation will be concluded by Mr. Matteo Martini, who is a principal research analyst in the area of thermal, automotive, supply chain, and technology. Matteo will be talking about the, of course, thermal domains at IHS Markit within supply chain and technology, automotive department. His primary focus lies in the areas of climate control, powertrain cooling, as well as hybrid and electric vehicles thermal management. Matteo had previously worked with a major OEM supplier for 13 years within engineering and project management, thermal division, both in Italy and in USA. So, and also Matteo is based in Italy. So we have 2 presenters from Italy and 1 from Korea. So with that, I will hand it over to Claudio that's going to start the presentation. Claudio?
Yep. Thank you very much for your kind introduction, and thank you too for the cooperation in this such of these great events. We are very excited to be part of this international opportunity to present our intelligent know-how. As I said, I'm responsible. I'm mainly working to the e-mobility portion, covering the domain of electric motors, power electronics, and charge infrastructure. And today, using the anniversary, the opportunity of celebrate 100 years of IHS Markit history into the data and forecasting, we will go through some of the main areas or main components influencing the e-mobility trends in the years to come. We will wrap up a bit the role of IHS Markit into the automotive industry today and our relation with all the major players. Going through the expectations in terms of vehicles for the years to come with an horizon up to 2030 with a special focus on the alternative propulsion segment. And then we will go, have a deep dive into the 3 main domains already presented, the electric motors portion, passing through the battery domain and having a great overview about the performance and the thermal portion thanks to the Matteo speak. So let me spend a couple of words about IHS Markit. Our company counts today about more than 15,000 employees on a worldwide scale, and which includes about 5,000 analysts working on a daily basis on all the relations between OEMs, suppliers, and on a worldwide scale across different domains, and with offices in more than 130 countries and speaking more than 50 different languages. So we have an international footprint, but with a deep, a strong regional intelligence. Within the automotive industry, we are located in more than more than 15 different key markets on a worldwide scale. So having access to the major automotive hub industries across the globe. And within the supply chain, remaining into the automotive industry, we do have different divisions covering the overall forecast in terms of data and supply chain and technology. We have colleagues producing the sales and production forecasts made on different inputs coming from all the other divisions of IHS Markit, as you see, for example, the fuel price, the policy and regulations, the trade and commerce, GDP forecast, consumer preferences. All this information gathered by our colleagues are taken into consideration on producing the future sales and future production volumes forecast. And then we have a dedicated team working on the powertrain and engine level, so creating basically the split of the future vehicles according to the right technology, so defining where the car is a gasoline, where a car will be a pure electric or plug-in one or mild hybrid, and so on. And then we will get our SGT, the components domain, where Hai, Matteo, and Richard are sitting on today. Our role is basically to take the volumes produced by our colleagues and to add our intelligence on a component domain. And this happens on 13 different domains for more than 130 different components. So let's get started with the alternative propulsion vehicle market, and with some figures of what has been today until today the alternative propulsion vehicle market, and what should be the future of this subsegment, or what we have to expect in the years to come from the alternative propulsion vehicle market deployment. So starting from looking at the past, of course, the presence of the alternative propulsion vehicle market has been relatively low, especially until 2019. Especially if we focus our attention into the first phase of the graph until 2015, we do see how the market has been stable over the years with a total production volume of 0.5 million of units across the different years. And then starting from 2015 until the last quarter of 2019, we have seen a significant growth of all the different applications of the alternative propulsion vehicles, which includes the mild hybrid ones, so the vehicles without a proper electrical range, passing through the hybrid ones, fuel cell technology, the range extended, plug-in ones, up to the pure electric vehicles. And if we look at the graph, we do see how the hybrid technology has been so far one of the main driver of this AP deployment, AP growth over the years, especially, as I said, until 2015. And then over the last few years, the role of the hybrid technology has been, of course, significant, but significantly decreased by the presence of all the other technologies. And we do see immediately how the mild hybrid ones have been interesting, increased over the years, getting at the end of 2019, seeing an important portion of the market, about 1/3 of the overall alternative propulsion vehicle market. The other topic is about the pure electric vehicle and the plug-in ones, so the orange curve and the blue curve. If we sum up it together, we will get that at the end of 2019, the chargeable vehicles, let's say, got a bit less than 50% of the overall market share, with a proportion, with a step towards the pure electric vehicle cars instead of the plug-in ones. But what do we have to expect about the future? And looking ahead with an horizon up to 2031, we do see the market still growing, of course, especially with the significant, with getting at the end of 2031, more than 50%, about 60% of the overall market share. Of course, displacing mainly internal combustion and start and stop technologies. And the second insight is about the main driver, or the big winner of this electrification wave, which is again represented by the mild hybrid technology. We do expect by 2031 a strong presence of the mild hybrid technology, getting about 50% of the alternative propulsion vehicle market, and getting more than 1/3 of the overall market in terms of production volume by 2031. Of course, the mild hybrid will be the big winner due to or thanks to main reason. The one is the perfect ratio between investments and CO2 compliance in some cases. Of course, the role of all the other technologies are anyway not negligible, with a strong increase of pure electric vehicle and plug-in electric vehicle, which is expected to become by 2031 more than 50%, or which is expected to get more than 15% as a presence by 2031. And in a sense of let's say following trend, we do expect the pure electric vehicle technology, the orange curve, getting more interest if compared with the plug-in ones, represented by the light blue curve. So just to sum up in terms of figures, it's interesting to have a comparison on a worldwide scale, on a regional base, having a picture of the worldwide situation. And we do see immediately how, especially starting from 2025, Europe and China will be the leader of this alternative propulsion deployment, with more than 70% of the overall market share for Europe and more than 50% for China, with a penetration rate by 2030 getting 80% of the overall vehicle produced. Of course, the Chinese market will be the leader in terms of figures due to the extended market, or the wider market than the European one. And but the European market will be the leader in terms of percentage deployment. And across the globe, we'll have the same picture of pure electric vehicles dominating or having more chances than the plug-in ones, if focusing the attention on the vehicle with plugs. This will happen apart the Japanese and Korean market, where we do expect a stronger position of plug-in electric vehicles if compared with the pure electric vehicle ones. So having done this portion about the alternative propulsion vehicle market, is overview, it's interesting to go and to look at the different components domain and how these components will be affected by this evolving picture of electric vehicles. I would like to start with the general picture of about electric vehicle markets, electric motor markets, with a time frame up to 2031. And as we see at the first glance, the biggest portion of the market will be represented by the mild hybrid technology, so confirming what is going to happen at a vehicle level, where we do see the belt application, the P0 application, as one of the main driver of this deployment. But today we will focus our attention on the e-axle portion of the market, which is expected to be about 20% of the overall market share, with the different combination, front e-axle, rear e-axle, or the twin solutions. And within the e-axle market, it's interesting to look at the technological trend in terms of technical choices for OEMs and tier suppliers. And we do see immediately how the market is already today mainly driven by permanent magnet solutions, covering more than 90% of the market. And we do expect a market growing fast, hitting more than 25 million of vehicles equipped with an e-axle by 2031. And we do see, of course, the permanent magnet solutions remaining the main driver of the market, getting more than 60–70% of the overall market. Of course, it's interesting to look at the trend, for example, of the current excited motor, which is represented by the dark blue curve here on the top. So the approach of free rare earth motors. Some tier suppliers and OEMs are clearly moving outside this adoption of PM solutions. That's the case, for example, of BMW, the 5th generation of e-axle of BMW, which is dedicated to the current excited solutions. And other suppliers are now moving in the same same direction, but we do see by 2031 the PM technology still as a main player of these technological choices. Of course, in some application of e-axles, we will see probably mixed solutions where the front e-axle will be probably equipped with induction machines or current excited, and the rear e-axle or the other e-axle will remain into the PM solutions. The other interesting highlights comes from the maximum speed of electric motors. This table summarizes a bit what we do expect by the evolving picture of the technological side of the e-axles. We do see a market today equally distributed across different ranges of power, maximum speed delineated into the table. The most interesting point is about the 20K plus maximum speed e-axle solutions. We do have already some applications like into the Ferrari ones today. We do expect a market growing in this higher higher rate of maximum speed over the years, with the range of 18K, 20K getting a plus of 15% by 2030, and we do see a market of 1% moving, clearly getting the chance of having 20K plus maximum speed of an e-axle motor. The other highlight is about the in-house and outsourcing. The make or buy is one of the main favorite questions for many tier suppliers who are really keen to know how will be the trend in the future. And having different discussion with OEMs and tier suppliers on a daily, weekly base, we are now defining this trend, and we do see on a worldwide scale, of course, an increasing trend of in-house production versus the outsourcing. Especially by 2026 onwards, we do see a market moving on more make than buy, with a market share of in-house hitting the 2/3 of the overall market if we focus our attention on the e-axle market and filtering out for the top 10 global OEMs. Of course, there will be some differences on a regional base, where, for example, the European market will be more make than buy, where the Chinese market still remaining more in behind, let's say, with still more buy than make in 2025 onwards as a time frame. Of course, there will be an evolution trend in terms of technology, and this will happen not just into the e-axle portion. One of the other interesting market is the one related to the inverters, and with a special focus on the switching technologies into the inverter portion. And having a split of the market for the mild hybrid technology, full hybrid, and pure electric vehicle technology, we can clearly see how the market will evolve in the future, and this will happen especially after 2025. We do see a market, for example, of the mild hybrid technology expected to remain into the MOSFET as the most used switch technology over the years, with some IGBT solutions coming after 2025 mainly. The situation is probably evolving faster into the high voltage applications, so full hybrid and pure electric vehicle technologies, with new technologies coming to the market, like the silicon carbide and GaN technologies. Especially by 2025, 2026, we do see a market clearly starting on adopting these technologies, and we do see how the market of pure electric vehicle and fuel cell will get more chances of a strong deployment of silicon carbide and GaN. Of course, this will be related to the technological choices made by the main suppliers. We have heard in the last weeks and months suppliers like ZF clearly moving the first steps toward, again, technologies, thanks to the cooperation with other switching suppliers, as well as the commitment of Vitesco towards a silicon carbide one. Of course, some applications are already in place, and the Tesla Model 3 is one of the examples, already adopting the silicon carbide solutions into the Tesla Model 3 as a first mover of this application into the inverter technology. The last portion is about the last trend that I would like to share with you today is about the integration level. And as we see from the graph, we do expect a market in the which is already really fragmented across all the different options, converging in some solutions, which tells us that the evolving picture is moving to the picture is evolving towards a higher level of integration in time. And as we do see immediately from the graph, the DC-DC plus onboard charger together with the motor and inverter integrated, so two boxes with two different level of integration, will be probably one of the most adopted one. And again, as an example, the Tesla Model 3 is already, and the Tesla Model S second generation is already equipping the car with this solution, where the DC-DC DC-DC converter and onboard charger are now mounted together into the passenger compartment, and the motor inverter are put together into the traction drive unit into the e-axle. The second level will be represented by the motor and inverter, which is of course one of the most adopted solution for the mild hybrid technologies. 95% of the P0 applications, for example, will be are shown as, and will be probably selecting the combination of the two components in one, integrated in one box over the next years. So I would like to draw some conclusions with you all. The first one is about on the vehicle side. The COVID-19 has been had an impact on the overall market, of course, impacting all the production volumes for the 2020 and for the next few years. Of course, the COVID has been mainly impacted the internal combustion and start and stop technologies. With we do see the electrification wave more resilient if compared with the traditional engines. And electrification is moving, is evolving, of course, and we do see this alternative propulsion vehicle market displacing mainly the internal combustion technologies. And by 2030, we do see a market of produced vehicles showing one vehicle every two produced with a certain degree of electrification. Moving to the axle market, as we have shown in the last slides, we do see permanent magnets technology still a significant portion of the market, and we do see by 2030 this technology still leading the way for the axle application, despite other technologies are emerging, and that's the case of the axle flux, for example, or the current excited solutions adopted by many OEMs or many players. The other side is about the in-house production. As we said, filtering for the main, the global OEMs, the top 10 global OEMs, we do expect a market of in-house versus outsourcing of hitting 2/3 of the overall production volume by 2030. And the last point is about the power electronics. We have seen the switching devices becoming more and more important over the last weeks and months, and we do see a chance of diversification in the years to come. And just looking at the inverter portion, we do see how in the future, especially for the high voltage application, new technology will appear, especially after 2025. And the last conclusion is about integration. As we said, we do expect in time a higher level of integration, offering higher efficiency, cost and weight synergies, of course, and this will happen on a platform scale or an OEM decision base. Thank you very much for your attention, and I'm happy to hand over to Richard for the battery portion.
And thanks, Claudio. Can you see the screen right?
Yes, we can.
All right. Thanks, Claudio. My name is Richard Kim, responsible for battery market research in IHS Markit Automotive. Today's topic is battery technology evolution for hybrid and electric vehicles. Okay, let's get started. The chart on the right represents the total lithium-ion battery market. Let's see. The lithium-ion battery market development from 2019 to 2030 by application. The portable electronics used to be the biggest market until 2016, but the transport sector is the new champion since 2017, and it became the dominant market. It expected to account for around 93% of 1.5 terawatt hour in 20. Sorry, I think there is a technical issue. In 2030. So the accumulated demand is forecasted to be 8.6 terawatt hour from automotive and transport sector. As you can see on the right side of the 2030 bar, the LV stands for light vehicles that our research covers. That interprets the contents of my presentation doesn't cover any type of medium and heavy-duty commercial vehicles and boats and trains in transport, and as well as the portable electronics and energy storage device. So please keep this in your mind when you listen to my presentation. Okay, back to the total demand of lithium-ion battery. Then this demand can be met by supply without any bottleneck. This is one of the most frequently asked questions in the market. So according to the battery service solution sourced from another part of IHS Markit business called Energy Team, the battery cell supply capacity announced by cell makers in 2025 is around 2 terawatt hours, so summing up the America, EMEA, South Korea, Japan, and China, which is about 2 times than the demand that we have seen in the previous slide. So by the numbers, the oversupply is expected, but we need to monitor whether the cell manufacturers will be successful in expanding capacity by raising enough fund in financial market or by itself. And more importantly, in this rapidly growing market, cell makers should make sure to achieve high yield rates and a low ppm of the production line. And in addition, there are a couple of more cell makers need to be added in the database from Europe and South Asia for your reference. So what I'm saying is, in terms of cell manufacturing, there are not so much supply bottleneck is expected in terms of cell manufacturing capacity. All right, that was about supply and demand of lithium-ion battery market. Now let's take a look at more specifically in automotive market. This slide shows you the 5 key parameters that car makers require for batteries: energy density, power density, lifespan, cost, and safety. Actually, the most important factor for OEMs is the cost. I think until additional willingness to pay for battery electric vehicles reaches the additional value of battery electric vehicles to internal combustion engine cars, the EV system cost should go down definitely in order for taking more market share, because EVs are much expensive than internal combustion engines. And as you know, in some markets, subsidies gradually phase out, and we are expecting that trend to be deployed to worldwide market. Consequently, the cost is the most important determinant influencing on our research today, and of course beyond. So this chart shows you the attributes and data of our ESD, energy storage device product. This data covers all relevant supply chain and technology data for from the top. The systems architecture is a just summary, and when it comes to the components, we covers from battery pack, module, cell, battery management system, and supercapacitor of hybrids and electric cars. I think you'll be able to see the details later because the letters are very small. And what I'm going to talk today is all based on the data we provide here. Especially, I will focus on the cathode and anode material of battery cell. And when it comes to the battery pack, I will talk a little bit about the battery pack enclosure materials for tray and cover. Here in this chart, in this slide, the two radar charts are made to highlight the 6 key technical factors that OEMs take into account for their the car development. What I'd like to emphasize from this slide is two. One is different propulsion type require different characteristics when it comes to battery specification, and the other is the most common important factor is cost, whatever the propulsion type is. When it comes to hybrids fitted along with internal combustion engine cars, without any doubt, the additional cost of battery should be as cheap as possible. And when it comes to battery electric vehicles, batteries for premium cars will have more room for the battery cost, but it is also under pressure because the battery is the most expensive component of battery electric vehicles. Therefore, all battery system related components from battery cell to battery pack and all thermal components and all pack enclosure materials as well are under development in a way of lowering cost as a mandatory parameter, meanwhile improving other technical parameters at the same time. So then what is the evolution in cathode material in these sort of circumstances? As you can see in the table, various types of cathode materials are available for different applications from LCO to NCM. When it comes to NCA and NCM, these account for more than 90% of light vehicle battery market as of 2019, last year, thanks to the advantage of energy density. On the other hand, these two types have disadvantage in cost and safety compared to specifically LFP. Cell makers and OEMs are making great efforts in order to mitigate this by adding more nickel or manganese, and with other various technical breakthrough. There is another cathode material called LFP here that is recently being shed on light by Tesla. It has been improving energy density, that is the weakest point, and now it meets the energy density requirements for subsidies in China in the end, which was the reason why OEMs didn't use for passenger cars before. So today, BYD Han and the Tesla Model 3 with the state-of-the-art LFP technology are expected to overcome the subsidy hurdle in China. Then let's take a look at the IHS Markit light vehicle battery cathode material market outlook here. As I said several times before, there is a tremendous pressure on battery cost reduction to meet the cost parity to IC cars. They can explain why we see high growth of high nickel NCM here, light green, and the dark green NCA chemistry. This one dark blue NCA chemistries. With the same region, if we look at the gray, there will be some propulsion types to be fitted with LFP chemistries in the future, as well as thanks to low cost and improved energy density. Upon the result of our research conducted just this year, at the early of this year, we are interviewing not only our clients but also prospects and research contacts playing in chemical, automotive, and battery industry. We will be continuously update the technological innovation by observing the market trends in the future as well. I would like to say, all of our researches are live forecast, which changes every month by taking inputs from various sources. Okay, what about anode materials? For now, graphite is currently used in secondary battery as a mainstream technology. Actually, it is largely divided into natural and artificial graphite here. But actually, the ratio between these two graphites in one battery cells varies by battery cell makers. And there is another technology called LTO with good performance in general compared to graphites, but high cost and low energy density compared to these graphites. And actually, it is the main supplier is Toshiba. And on the other hand, the use case in light vehicle sector is as for LTO is very limited, as you will see in the next slide. And when it comes to pure silicon and lithium metal anodes these are still in laboratory level, which means there are many things to do in terms of resolving technical issues as well as commercial issues. Therefore, we think that it will take a long time until those are broadly adopted to light vehicle battery market. So if we look at the market share by anode type as of 2020, as you can see here, the majority of lithium-ion batteries are using graphite, combining natural and artificial. And some cell makers like Panasonic blends less than 5% of silicon oxides to graphite. In the meantime, we expect that more cell makers are adding some portion of silicon into graphite for the sake of increasing energy density and improving charging profile. Okay, I should be quick considering the limited time. So now let's give a little attention to battery pack enclosure material. I tried to describe the advantages and disadvantages of each material, as you can see in the table. As always, one doesn't fit all. So this gives you general use cases. So I hope you could see the details later. And let's move on to the next page. So I want to talk about the market share by technology. We do have two different research fields in our database. One is for battery pack cover, as you see in this chart, and the other is tray, including not only on the cover, but also the structure inside the pack. This chart shows you the percentage change of each material out to 2031. and I just want to tell you an example of many applications. Unlike the three materials that you will see in the next slide, there are more SMC, standing for sheet molding compound, a sort of a thermoset plastic than in tray, because upper part of battery pack located even under floor of car doesn't require any severe technical characteristics such as anti-chipping and rigidity. So that is why you are seeing the SMC big portion in battery cover. In this slide, I want to take aluminum use cases for battery electric vehicles, pack enclosure tray. When it comes to scalable battery pack, such as MEB platform, the engineers should think about the scalability of longitudinal length diversity. For example, in this case, profiles made by aluminum will be the most suitable technology to apply. Because of this sort of engineering requirement and technical characteristics needed for battery pack tray, resulting in high share of aluminum in this technology. Please let me summarize what I presented today. Being conscious of time, I don't want to spend much. I don't want to read all the sentences here, but consequently, the third sentence in bold will summarize the best what I would like to deliver today. The cost will be the most important factor for OEMs and component suppliers to consider while meeting safety requirements in principle. As I said earlier, technology is performing better in different aspects with remarkable cost increase. Cost increase wouldn't be able to uptake in most segments of light vehicle sector. This is my key takeaways. So please, I wish you could read it, and please come back with some questions too. In regard with these summaries and my contents, and yeah, just feel free to contact me once you come up with any questions. That's it, and then I will hand it off to Matteo for now. Matteo.
Hello, thank you, Richard. Okay, this is, hello everybody, this is Matteo Martini from Thermal Domain IHS Markit. I will bring you today through performance, efficiency, and longevity through optimum thermal conditions on battery electric vehicles and hybrid vehicles. So first of all, let me start with this brief introduction. What is the impact on electrified vehicles on thermal management compared to internal combustion engines? So we have identified 4 additional modules that are required for an electrified vehicles compared to a conventional one. The first one is battery, because it requires thermal management other than being heat or being cooled. Then the other 2 are power electronics and electric motors, which requires some sort of cooling strategies. And the third one, which is already present on an internal combustion engine, I mean the air conditioning system, which in case of electric and hybrid vehicles, because of the lack of waste heat, requires to deliver some sort of heating strategy to the cabin, meaning that some sort of supplementary heaters or an heat pump system is required to perform this task. Today, we will be focused on battery, power electronics, and electric motors thermal management. Starting with electric propulsion cooling strategy, I have split our data into cooling medium strategy for battery electric vehicle and plug-in hybrid vehicles, and hybrid vehicles in general, including plug-in. As you can see from these 2 charts, battery electric vehicles are very much focused on cool and cooled strategies, while the market is significantly more split between coolant-cooled and oil on the hybrid side. This because on the hybrid vehicles, transmission and electric motor are more often integrated. This trend will enter also battery electric vehicle, but in a smaller scale. A smaller percentage of vehicles, both on battery side and hybrid side, is air-cooled, of course, to keep costs low. Not very much to say about the inverter, where the overwhelming majority of cooling strategy is coolant-cooled. Again, also in this case, a small percentage is air-cooled to keep the cost down. Moving into the battery thermal strategy, this is an oversimplification of why some sort of battery thermal management is required. Below a certain temperature, approximately 10 Celsius degree, battery reduce its performances, while on the other side, above approximately 40 degrees, battery starts to age quicker, and even there's a chance of thermal runaway approximately above 60 Celsius degree. This optimum operating range is significantly smaller than the ambient temperature where a vehicle is required to operate. Therefore, heating is required in case of low temperature condition, and cooling is required in case of high temperature condition. We see from the market these different strategies of cooling. The first one is forced air. This is safe, simple. It just requires a fan system conveying air into the battery pack. In some cases, many cases, it also adds an evaporator which spills refrigerant from the air conditioning system to further cool down the air. And it is vastly adopted by Chinese automakers. Next one is refrigerant strategy. In this case, evaporator plates are required within the battery pack. It is a high-performance system. It is lightweight. On the other hand, is fairly costly and difficult to set up. One of the first adopter, if not the first adopter, being BMW i3. Then the next one is coolant-cooled battery, using a mixture of water and ethanol glycol. This requires a significant number of additional components like cooling plates within the battery pack, additional radiators, additional chiller, and water pump to let the coolant flow. Of course, this is a proven technology since it is very similar to internal combustion engine cooling strategy. It is efficiently and vastly adopted by the market. Then the next one is dielectric fluid or immersion cooling. It is not too dissimilar from the previous one. Basically, instead of having cooling plates, the entire battery pack becomes the fluid housing, and battery modules are directly immersed into this dielectric fluid, which has very low electric conductivity. Therefore, it is safe to have cells directly immersed into that one. It is high performance. We know it will come in the market soon on a high performance sport car, but in this moment we believe that this will remain a niche application, and therefore in our forecast it is not a separate one, but still included within the coolant cooled batteries. The last one I would like to mention is phase change material. This is usually not a separate strategy, but an add-on to other cooling system. It is basically a filler within between battery cell and battery module. This material change phase between solid and liquid by absorbing it, and it helps smoothing transition of temperature or reducing the system load in case of extreme condition, but it is not usually used on its own. In terms of data, this is what we see. Battery electric vehicle market is very much dominated by coolant-cooled battery, and we expect these to increase in the future by reaching 2.8 million coolant-cooled vehicles by 2026. On the other side, hybrid vehicles are mostly using forced air because of less performance requirement by the battery pack itself, and this trend is expected to shift slightly in the future, but still keeping the cost as the main driver. The majority of battery will remain as with forced air even up to 2026. Looking at the combined market, we expect that more than approximately 55% of the market, the combined market, will be equipped with coolant-cooled batteries by 2026, meaning that the demand of electrically driven water pump, cooling plates, battery radiators, and chiller will increase significantly. Still talking about battery cooling, as in some condition, just exchanging it with between the coolant system and the ambient air is not enough. There is need to spill some refrigerant from the air conditioning system, meaning that the compressor should operate even when the engine is not present or it is off, because the electric motors are operating on hybrid vehicles. This means that the compressor is transitioning significantly from a belt-driven compressor to an electrically driven compressor one, and its market share will increase from now up to 2026, moving from 5 million of electric compressor produced last year up to 22 million electrically driven compressor expected by 2026. On the technology side, this means that while between 2000 and now, we have seen a very negligible shift in terms of compressor technologies. We expect in the future scroll to become significantly more relevant than piston, and recovering some ground on piston compressor, as basically all electric driven compressor are scroll type. This will mean that having the mechanical part very much designed as a scroll type, the development will shift from the mechanical side to the electrical one to improve efficiency and performance. Moving into the 18 strategies of the battery. Again, also in this case, we see a polarization between battery electric vehicle and hybrid vehicle. In case of hybrid vehicle, again, because of less performance requirement, most of the battery has no heating strategy, and there will be no significant shift expected in the future, with just a small percentage equipped with the high voltage coolant heater. On the other side, battery electric vehicle, which are already half of them, which are already basically equipped with some sort of heating strategy, will shift from current strategy split between high voltage coolant heater and heat recovery strategy to use the coolant heater as their main heating strategy in the future. A small percentage that will increase slightly but not will become dominant is using the heat pump system, which equip the air conditioning system to also warm up the battery. Finally, to wrap up my presentation, liquid cooling, either oil or ethylene glycol and water, will dominate electric motor and inverter cooling strategy. This in order to ensure optimum operating performance in the whole ambient temperature range. On the battery side, we see that battery thermal management market is basically split between a battery electric vehicle favoring coolant and performance, while hybrid vehicles still prefers air and cost competitiveness. Lastly, on the heating side, we see that in search of optimum performance, battery electric vehicles are forecast to increase the utilization of high voltage electrical heaters, but despite this, market share is not expected to increase significantly because of cost constraint limiting their application in low vehicle segments. Thank you for your attendance. I will hand over to Amit now for the Q&A session.
Well, thank you very much, gentlemen, for an excellent presentation covering a wide variety of topics here, starting with the general overview of the market and then making a deeper dive to the critical elements of the battery electric vehicle, mainly the e-machine, the inverter, and the batteries. And of course, the thermal management, as Matteo just covered. It was an excellent presentation, and I thank you all for it. Now we can get to our Q&A session. I'm trying to open up this window, looking at all of the submitted questions, and I'm having a little bit of a difficulty here because most of the questions are covered here. But we have had a number of questions submitted already. And I would like to start with a question that was submitted by one of my good friends and colleagues, and actually my previous boss at GM. And it has to do with the alleged tipping point for BEVs. When do you guys think this alleged tipping point will happen? Of course, we have seen some charts looking at the growth, but it seems like it's a steady growth. But there must be a point in time where we can put a dart on the page and say, okay, this is the tipping point. What do you think?
Hey, I think I can cover this question. Are we talking about price? I assume, right? The let's say the price parity of the two engines or the two systems. I will say we are not really properly covering the pricing of all the components, or we are covering just in terms of business domain. So we cannot really have a fair opinion on when this will happen, also because it changes a lot according to the different scales, different volumes. We do see, of course, a steady growth of the pure electric vehicles cars. So we are not thinking about many cars coming to the market and, let's say, displacing all the existing rules. We do see something not achievable, by the way, in the next few years. So I would say that we are talking about the range of 2025 onwards, perhaps 2030 onwards.
Okay, thank you. And you mentioned cost as being one of the main factors. Richard, the charts that you showed, the spider charts, talking about the cost, was that initial cost of manufacturing, or was it life cycle cost? Obviously, the batteries need to be replaced and they do not have an infinite life. So there should be a life cost factor involved. Any comment on that? You're muted, I believe.
Can you repeat again the question again?
The charts, the spider charts or radar charts that you showed.
Yeah.
Was the cost data initial cost or life cycle cost of the battery?
The initial cost.
Okay. What about life cycle cost?
Well,
Obviously,
if you are talking about life cycle cost, you know, it shouldn't be a different scheme, because, you know, in this case, you know, we have to consider about the replacement of the cost, and, you know, so in this case we have a different scheme. So we are conducting the researching around the total cost of ownership. So I think this should be addressed in a different way. So I think if we finish this research, I think we can give you some sort of reasonable qualitative research result in later. So, but for now, I don't think I can share any details about that.
okay, thank you. A question that's been submitted, which has to do with the method of cooling you think would be dominant in the future. Can you comment on it?
Well, we already see from our data that in terms of battery cooling strategy, of course, coolant will become dominant. Also because battery electric vehicles are expected to increase significantly more than hybrid vehicles. So the market is already polarized towards coolant, and this will become relevant. Also, on the other component, or on the other relevant components that we see that we are aware of in the vehicles, coolant is significantly the dominant strategy. This allows a sort of combined strategies between batteries, inverters, motors. Everything can be looped into connected circuits, allowing for heat recovery strategies or any sort of advanced cooling system or air conditioning system. So definitely the direction is towards coolant strategy.
Okay, thank you. What is your view on the last mile delivery solution, especially for crowded cities? There's a lot of talk about the last mile delivery options with small truck applications. Does your study cover something like that?
Well, it doesn't really, but let me start from the thermal perspective. Well, you see from our data that well, just to contradict what I just said. So a small portion of the market is still lying towards air-cooled systems. This because on small vehicles, cost is very much the main drivers. So air cooling strategy is still the cheapest one by far, meaning that any type of vehicles performing light duties or small or very short driving range, of course, keeping the cost down is relevant, and going for air cooling strategy is surely the direction.
Okay. By the way, does your studies cover the commercial vehicle, light commercial applications by any chance?
Well, actually not. Our data are related to light vehicles up to 6 tons. So no, light vehicle, commercial vehicles are unfortunately not covered.
Okay, I realize that the data you showed today is all light-duty vehicle, but there is a question from one of the participants asking whether you have such a study covering commercial vehicles, commercial applications.
Well, we don't from the supply chain perspective. So we cover from the vehicle perspective. So in terms of production data. So we have a dedicated team working on medium and heavy duty commercial vehicles, making forecasts on vehicle, but not down to supply chain strategies.
Okay, good. Claudio, a question for you. You talked about the e-axles and the different technologies going there, but there was no mention about the multi-speed e-axles. What do you think about the, for example, 2 speeds? Do you think that is necessary for the C and D segment vehicles or not?
Oh well, the real reason why I didn't mention it because this is not under our responsibility as a supply chain technology team. So it's all the mechanical portion of e-axle together with the transmission side is under the powertrain responsibility. So this is for us still not an input and cannot be an output. Of course, many suppliers are working on that. It's hard for me to say if there will be a trend and if there will be an added value in some cases, just because it's outside the range of our research. So unfortunately, sorry for that.
Well, I realize that, and I don't expect you to talk about something that you have not really covered here. Richard, a question has been submitted here, which I think you can answer it. It says, which is the most important thing to increase EV range? Is it the cell, power density, energy density, or is it the module thermal control?
Well, it is.
I know it's a loaded question, but
Yeah, the battery electric vehicle system is pretty much complex. You know, there are so many independent variables to influencing on the battery driving range. Of course, battery cell will influence because of the energy density in a very limited space, and considering the weight, the energy density of battery cell should be very dense. The energy density should be higher than if in this case the OEMs can store more energy in a same space. That will increase the BEV's driving range. At the same time, the thermal system will also influence because that will also, influence on the battery driving operation ranges and conditions. So in this case, this will also influence on the charging and discharging capabilities. So this will also influence. And if motor and other motor and power electronics, technological solutions will also influence. So all in all, if I should pick up only one very most important factor influencing on battery electric vehicle driving range will be, I should say, the battery energy density in a way of battery pack, because if we compare these two technologies with the conventional lithium-ion battery and solid-state batteries, then energy density might not be so much different in the cell level if both use the same anode material. However, the solid-state battery could remove or eliminate the thermal system. In this case, the pack can be filled with more battery cells in the pack. So I want to say that the battery pack energy amount will influence the most on the battery electric vehicle driving range.
okay. How about what about solid-state batteries? Do you see a future? And if so, when do you think they will become a reality?
Well, this is a very good question and interesting question, and so many frequently asked question. I think it depends on the scale and the level of technologies. What I mean is there is a solid-state batteries commercially available and fitted to cars in the market already. So, but however, the technological specification of that solid-state battery is far behind the market expectation for now. So when it comes to the level of solid-state batteries, I think it is likely to be more no earlier than 2028 to be applicable to mass volume cars because of the technological obstacles and commercial perspective.
Okay, great. Now, since we are on the topic of batteries, let me ask you another question in this area. What do you think would be the dominant voltage for the battery packs going forward? I mean, we have been seeing voltages all over the map with different applications.
Yeah, in order to discuss this topic, we should think about not only cars voltage system, but also the charging infrastructure voltage as well, the power. Because you know, if the charging infrastructure is not ready for that high voltage system, that you know the high voltage system wouldn't be not so much beneficial. Meanwhile, increasing despite of the increasing cost of the battery electric vehicles. But for now, I think premium the electrical system for premium brands definitely they are going for more than 800 volt, which is called 800 volt system. But you know, the majority of premium the public brands will go for 400 voltage system, until the 800 voltage system could reach the how should I say, the majority until the 800 voltage system could be the mainstream technology in the market, could achieve the reasonable price. So the 800 voltage system will be a niche market until that time frame, and then I think premium will brands with high amount of energy, you know, car energy per pack, you know, car will go for that high voltage system.
Okay, great. Claudio, there is a question here that has to do with the lubricants and fluid development. How can they improve the EV driveline systems, and what are the challenges that should be improved or addressed? Of course, you know, there are different aspects to this. There's fluid for the battery cooling, but I think this question has to do with the e-axle cooling and lubrication, and e-motor, of course.
Yeah, of course. Perhaps Matteo is more on the ball on this topic. I don't know, Matteo, do you mind to jump on it?
Well, I have a fairly simple answer to this question. So what we see is mostly driven by integration. So having transmission integrated with the electric motors, of course, even in the case of any axle, oil is becoming dominant because of the simplification of the system, because it provides cooling and also provide lubrication for both the transmission and the motor itself. So as much as the integration will progress, oil is becoming more relevant. So on the e-axle side, we expect that oil, I don't exactly know what type of oil, but oil will be fairly much dominant.
Yeah, just let me add on this point that of course integration is growing, and as we have seen into the presentation, and for the axle this will be the main driver, with the 3-in-1 as a favorite choices for most of the old applications, excluding some partnership or tier suppliers or OEMs decision.
Mm-hmm. Do you see a significant development in the area of ultra low viscosity fluids for e-axle, the transmission, the gears and bearings and all of that, at the same time adding dielectric components to it? If you have to cool the electric machine as well?
Yeah, within the e-axle, the inverter will be in most of the cases integrated with the motor and the reduction gear. So we can typically say that will be a 3-in-1. Of course, it depends on case by case, because in many cases we have suppliers advertising 3-in-1, which is not really feasible in practice. So, but of course, as a general answers, we do see a market of the inverter integrated with the motor and the transmission for the axle market.
Okay, Good. Here's the next question is actually for the entire panel here. Between BEVs and PHEVs, which one will be more popular in the future? What do you think? It's a loaded question.
Interesting question.
It's not exactly our domain, but we can tell what we see from our colleagues' data. So in a medium term, let me say by 2030, well, it will not be neither BEV or hybrid vehicles. It will be mild hybrid. It's the most cost-effective way to reach regulation targets. In a longer term, yeah, go ahead, Richard.
Go ahead.
Okay. In a longer term, we see that battery electric vehicles will become more relevant, mostly because they are significantly more simple. So more can compete into this market, lowering the price, while making a hybrid vehicle operating at its best, it's significantly more complex and in a longer run, more costly.
What is your definition of a longer term? Sorry,
may I add my perspective? May I add my perspective?
I'm sorry, say that again.
Can I add my perspective, my comments?
Certainly.
Yeah, so I think the answer is depending on the clients, the end users. They will choose BEVs and PHEVs in the end, so they will know the answer. But from our data, according to our data forecast, you will see that higher portion of BEVs than PHEVs, as you see in Claudio's slides. So the analysts are doing a survey, and they are contacting OEMs and suppliers, and they are researching the technology. So that is the result of a few hundreds of analysts, the research. So I want to say, BEVs will, the market share of BEVs will be bigger than the PHEVs in the future until out to 2030.
Okay, so we cannot really pinpoint a tipping point here, right? Okay, sorry, I didn't mean to press you guys on this $64 million question. Here's another question that has been submitted, and it goes like this. Does it make sense to allow BEVs to pull a trailer? Obviously, we have seen some developments, some announcements here in North America about battery electric trucks, and pulling and towing is a basic requirements of the trucks. But for small passenger vehicles, does it make sense to allow them to pull a trailer? Claudia, you want to take that on?
All right, this is a very interesting question, but in my perspective, this is not gonna be technically feasible, and OEMs wouldn't accept this feature on their C or B segment cars, because its body shape is much weaker than the light trucks or bigger SUVs, which are based on frame body, because these are based on the unibody. So I think they wouldn't willing to offer that sort of features for that sort of small segment cars, in my perspective.
Any other comments on that?
I will tend to agree with Richard, but honestly, nothing too much to say on top of that.
Okay, now since you are talking, what do you think would be the dominant type of e-axle, especially when it comes to the gearbox part of it? Will it be a lay shaft design or a planetary design?
Okay, good question, because we are still back in, we are again back to the transmission, the mechanical part. So frankly speaking, I really do not have any strong insight on that in terms of future. Yeah, unfortunately.
Okay, all right. Matteo, a question that has been submitted, I think you can address this. It has to do with the fast charging systems and the impact on cooling systems and cooling requirements. Can you expand on it, please?
Yeah, there are many news around this one. So some are saying that well, current thermal system designs are not enough to meet increased requirement of fast charging. Others are saying exactly the opposite. Well, we expect that current design is I mean, with cool-cooled battery is very much enough to satisfy a requirement. Probably it just requires some boost on the water pump side, so even increased coolant flows, probably a larger radiator, a little bit more powerful compressor, but not a big shift compared to current design. On the other side, we still don't have big data to support this. It seems like the limitation is more, again, the thermal limitation is mostly on the infrastructure side, because on that side, again, you need to cool down the charging plug to increase fast charging.
Okay. Richard, what about battery recycling? Does your study cover any data on battery recycling requirements, capacities? Obviously.
Well, actually, we do research the market for the installation for the cars. So we do not research the recycle market or aftermarket. But if I share my ideas and my knowledge about that market, well, there are just EV market is just starting taking off. So there is the after use batteries from battery electric vehicles are kind of reasonable to store in specific place, especially for OEMs or aftermarket places. However, as time goes by, the batteries will go out to the market. In this case, there should be some solutions to reuse or recycle the batteries. So there are a bunch of suppliers are working on this. But as for reuse, there are companies are saying, it is not so much valuable to reuse by spending some money and efforts to, classifying the level of, quality of the battery packs, modules, and cells in the end. So there are the economies. That solution is not so much economical, and many are saying that the batteries can be used for energy storage device, but the suppliers and makers are saying that the energy storage device requires deep DOD. I mean the depth of discharge, and then the cycle time is much higher than the battery electric vehicle, which is designed for automotive use. So all in all, I mean, there are many companies are developing the technologies. So I think that there should be some solutions to be applicable in coming years, like 3 to 4 years. But reusing the technologies for the energy storage device wouldn't be very much difficult. But there are also niche markets, such as using that battery for the charging infrastructure, for example. In this case, some are seeing the feasibilities. So that is about reuse. But when it comes to recycle, the supply chain should be closed. Otherwise, we should, mine more nickels forever. So we should find a way to recycle nickel, lithium, and so on, the valuable rare earth materials.
Okay, good. Thank you, gentlemen. We have already reached at the bottom of the hour, and this is the time that was allowed for this webinar. But let me ask one last question, and feel free, anyone, to answer this. Do you guys think that the fuel cell is already dead? And would there be any advancement in this area that would make it a viable alternative to battery electric vehicles? Any volunteers?
I mean, I can take it on. Let's say again, mentioning our colleagues' data. As we said, we used to work on the components domain, attaching our intelligence to the existing data of our colleagues. So, relying on the data of our colleagues, we do see a penetration rate of fuel cell. I wouldn't say they are already away. We do forecast the fuel cell vehicles in the years to come, even in the longer forecast. But talking about numbers and presence, we do not see fuel cell taking an impressive role in the years to come. So we are talking about few percentage figures over the next years.
Yeah, Claudio
Okay.
was talking about the passenger car market, but when it comes to mid
Correct.
heavy duty commercial vehicles and other markets like power plant and so on, then there should be some chances for fuel cells. But if we talk about transportation sector, everybody is almost the argument is that that technology is suitable for the mid heavy duty commercial vehicles rather than passenger car market. So once they could achieve the reasonable cost target for the system, then it could come to the light passenger cars. But once they are not able to reach the cost target, then it's going to be very difficult to apply that technology to light vehicle segment because of the high system cost.
Okay, great. Well, Richard, Claudio, and Matteo, thank you very, very much for an excellent job in presenting the latest technologies and trends in this very important area. I would like also to thank all of our participants from around the world who have participated and submitted questions. At this point, I would like to close this session and turn it over back to Sylvia for any closing comments. Thank you, gentlemen. Goodbye.
Thank you.
Thank you.
Thank you.
Yeah, thank you also from my side to the speakers, to the experts from IHS for today's webinar, and for Hamid for moderating this webinar and sharing the Q&A. I found it a really, really interesting Q&A, a really long one. So it looks like the audience enjoyed the topic and the information delivered, and there's a lot of interest in this topic, in this specific topic. So I'm looking forward to share the slides and the video with those who haven't had the chance to attend to other reasons today. So, and for those who have attended today, we will make it available within the next few days, so you can follow up with the slides and potentially also again with the video, and you also can share the link with your peers. Yeah, as said in the beginning, we will have a CTI symposium coming up mid of October, the first online event we will have, and it's exciting time for us. We are really, really looking forward to an interesting online conference. So far, I can say that 99% of the speakers have agreed to be available online and live for the US online conference. So we are glad that nobody skipped his presentation for the reason that we had gone online or decided to go online instead of being on site, which we really find it a hard and a tough decision for all. So be excited to come to our online event, and we will be happy to meet you there again. And we keep you posted and informed, so stay safe, stay healthy, and thanks to all the contributors and to the audience. Thank you so much. Bye-bye.